Today, what we're going to do is we're going to answer the questions that go along with our tide graphing activity from Hilo Bay tide measurements that we looked at on Tuesday. So I have my graph pulled up. If you have this on paper, you're going to want to make sure you have that out. If you have it online, go ahead and make sure that that is open. If for some reason your graph does not look like mine, then please make sure that you spend some time to make sure that it does so that you can answer these questions correctly. To get back to your assignment, click on your classwork tab and scroll down to assignments. So the first one should be beginning of the day check-in. I do want you to do that as well if you haven't already done that. Vocabulary words and assignments right here. So our tide graphing activity. This is the link to the data if you need that. This is our graph, our blank graph. If you worked on it on Cami, that should have your annotations still on as well. And then tide application challenge and challenge activity. These are the questions that we're going to answer. If you would prefer the questions in Spanish, aquí tenemos las preguntas en español. So if you open this assignment, there's a little bit of instruction, and then you're going to answer the questions. We've already gone through all of this. We graphed our data points. We repeated the steps for each date, graphed low, high, and then we connected the points. We're now going to use our graph to help answer the rest of our activity questions. So use your graph to determine the day with the largest tidal range. So what we're looking for is that greatest difference between our highest high tide and our lowest low tide. So go ahead and look through these points. We're looking at the biggest difference between these low points and the really high points. So what I notice is that our lowest point is one of these 2 days. And you can kind of peek at your data too if you need to figure out which date is actually lowest. Sunday the 11th should be negative 7/10. So that's going to be our lowest date. And then we're looking for our range. So we're looking from the biggest difference between the lowest and the highest point. So that's my lowest date. My highest tidal range is going to be, if we just follow our points, this one looks like it's going to be the highest. This one is actually 3.2 or 3/10 of a foot. So Sunday the 11th has our greatest tidal range. This is our highest tide, and that is our lowest tide. So on what day did it occur? It occurred on Sunday the 11th. And then what was the range? So you're going to take 3.2 and see if you can subtract to find that difference. So what is 3.2 minus negative 0.7? Negative 0.7. You need to use a calculator to do that. You are more than welcome to do so. Number 2, find the day with the smallest tidal range. The smallest tidal range. So the smallest difference between our high tide and our low tide. And you're probably going to want a calculator on that one as well. But if we're looking at these points are also high tide and low tide. Remember when we experience tides in 24 hours, we have 2 high tides and we have 2 low tides. So this is our highest high tide, but this is also a high tide. This is going to be on the side that's farthest from the moon, because if you remember, there are 2 things that affect an object's gravitational pull. 2 things. That's going to be the object's mass, and then the other one is the distance between the 2 objects. So that far side of the ocean that's on the other side of the Earth, that's not pulled on as much by the moon's gravitational pull. So that high tide is not as high as our side that's closest to the moon. So look through these points and see if you can find which 2 are the closest together. This one you can see pretty well, even without any math. So if you look for these 2 points close together, this low tide, high tide, low tide, high tide, low tide, high tide, which date do you think those points are closest together? go ahead and write that down. Now, I may not tell you all of the answers within this assignment, but I will at least give you a good hint. So make sure that you're watching and following along with the video. So our lowest tide, go ahead and write down the date for the lowest tide, tidal range, sorry. And then what was the range? So you're going to subtract those 2 points. If you can't quite tell what these points are, it's kind of hard to do when you're on the computer, and we kind of had to guess because, or not quite guess, but just kind of put them in the best spot because there aren't lines for every single minute in the day. So you may need to look back at your data points, but you're going to subtract. What's this point represent? The first data point for Friday and the last data point for Thursday. So subtract those two numbers. Then another number one. A flood tide is a rising or incoming tide between low tide and high tide. So rising means the water is moving from low to high. An ebb tide is a falling or an outgoing tide between high tide and low tide. So as it's moving down, that's an ebb tide. On what days and what times do you expect the strongest flood tide? When do we see that water move the farthest from the lowest low tide to the highest high tide? And that's actually something that we looked at earlier for number one, the greatest tidal range. So moving from our lowest point to our highest point. What date do we see our strongest flood tide? And then for B, when do we see our weakest flood tide? That smallest increase. That smallest increase. So these are moving from low tide, these kind of middle points here. We're moving from low tide to high tide. So which one of these is just the smallest? We don't see much of a change at all. What date do we see that happen? Now, it also asks the day and the time, so make sure that you're putting a general time here. C, when do you think we see the strongest ebb tide? And remember, ebb tide is when it goes out. So we're looking at the biggest motion away. So I would look between these two here, between Sunday and Monday. And you may need to look at your data points, but I would go here because this is going to be a special date. And if you look at your data, it says that Sunday the 11th is a new moon. And if you remember, our new moon is when we have the sun, the moon, and the earth, and they're all in a straight line. We also added some information to that when we started talking about tides on Monday. But when we have that straight line, we create what's called a spring tide, because there's so much gravitational force lined up between the sun and the moon that it really pulls hard on that one direction. So our high tide is really high and our low tide is really low. So looking at our strongest ebb tide, when that water really moves down, what date do you think it would happen? And what time do you think it would happen? And then the same thing for D, we're looking at our weakest ebb tide. Weakest ebb tide. When do we think we see that weakest pull? So this is going to be where that outgoing tide doesn't move very much. It doesn't move very much. So is that going to be Wednesday the 14th? Friday the 9th? You're going to need to probably do some math on this. Look at what this data point is. The first data point for Wednesday and the second data point for Wednesday, and the first data point for Friday and the second data point for Friday. Those lines seem to look like they are the most similar, but if you do some math or maybe kind of count some lines here, you can figure out which one of those is shorter, and then that's going to be what we predict is our weakest ebb tide. And why do you think Thursday, July 8th, right here, and Wednesday, July 14th only have 3 tidal heights. I told you that we have 4 tidal heights within a day. We have 2 high tides and 2 low tides, but these data points don't show that. They don't show that. So why do you think so? I'll give you a hint here. If you're looking at your data points, we'll just follow any of them. We'll follow one. Let's start with our very first data point. This first data point looks like it's before 6 a.m. and then we're at 6 a.m. Now we're a little after 6 a.m., about 7 or 8-ish. This one is closer to 9. This is after 9. And this one's close to noon. So what's happening to those data points over time? And then if you remember, we watched a video about the moon in our Nearpod lesson Monday that said that the moon changes position in the sky every day, and it will hit the same spot about 50 minutes later. So its position changes because the Earth's rotation, and then the moon is also revolving around the Earth. So just think about how that 50-minute change might change our data points and what that means for our 24-hour period. Number 3, draw the location of the moon in relation to the Earth and the sun on Sunday, July 11th. How do you think the moon phase affected the tides? So what you can do here is double click on your activity because this should make a copy for you. Double click on it and make sure, or you're going to insert, not double click. You're going to insert a drawing. And to draw in that, it's going to open up a box and draw a picture of the sun, the moon, and the Earth. Now, I already told you what order they were in. I just told you again. But our data set tells us that the Sunday, the 11th, is a new moon. So add a little text telling me how that affected the tides. If you're not sure, go ahead and rewind this video. And I did talk about that during our strongest ebb tide and our strongest flood tide for this second number 1 up here. Now, the second part to that is, how do you think the tides will be different on July 18th? Draw the location of the moon compared to the Earth and the sun on July 18th. So if you remember, it takes about 4 weeks for the moon to completely revolve around the Earth, to make one full revolutionary path, one circle. So if that's the case, it's going to take about 1 week to go a quarter of that path. So what phase happens 1 week or a quarter into our lunar cycle? So we start with new moon. 1 week later, we're going to have, or one quarter into the path, 7 days after a new moon, what are we going to see? That's what you need to draw for this piece right here. So again, you're going to click insert at the top of your screen and then drawing. And you're just going to have to make a new one real quick. There should be a little plus sign drawing. Number 4, assume that you live on the shore of a bay that's 20 feet deep at high tide. The entrance to the bay is over a rocky ledge, which is only 10 feet deep at high tide. The tidal range is 4 feet. What would be the depth of the bay at low tide? So thinking about this question, we'll just start with the A. What would be the depth of the bay at low tide? So you live off the bay that is 20 feet deep at high tide, and the tidal range is 4 feet. So it only changes 4 feet. So at 20 feet deep, that's high tide. Our range is 4 feet. So how high would the water be at low tide? If we start at 20 feet, that's our high tide, and we drop only 4 feet, our low tide at the bay is going to be 16 feet. 16 feet. Now, same thing for B. What would be the depth over the rocky ledge at low tide? The rocky ledge is 10 feet deep at high tide. 10 feet deep at high tide. And the range is 4 feet. So, what are we going to have to do to figure out how high low tide will be during B? Go ahead and figure that out and type your answer. Number 8. The average tidal range in Hawaii is 1 meter, or approximately 3 feet. Hilo is a small, funnel-shaped bay on the island of Hawaii. How do you think the shape of Hilo Bay affects its tidal range compared to other areas in Hawaii? So if you notice, there's this big rock wall here. So it kind of creates a funnel effect where the water can only go in and out through this area. How do you think that that's going to affect the tidal range? I want you to just think about that and come up with that on your own. Now, number 9, I'm going to go ahead and make extra credit. But you are piloting a fishing boat with your grandfather and want to go to the fish market dock in Hilo Bay on July 10th to unload your fresh fish. The fish market opens early and your fresh fish can be unloaded between 3 a.m. and 5 a.m. Your fully loaded boat draws 3 meters below the water line. The water under the fish market dock is 7 feet deep at zero tide level. Are you able to deliver your fish on time on July 10th? Why or why not? If you're going to do number 9, make sure that you read the question very carefully. Check out your graph because these dates are marked on your graph. And make sure that you explain as best you can. Make sure that I really understand your thinking so that you can earn points for that question if you want to attempt it. Okay, so make sure that you use your graph. I will also post a picture just in case, but I'm not worried about your graph being turned in right now. I would like to see it when you return to school. If you are a full virtual student, just send me a picture. But I do need all questions turned in. Because we are all at home today, everyone is going to complete the Tide Application Challenge activity